Okay, this is question 69 on page 396 in chapter 4.1 of our textbook. The question asks us to find the inverse function of f, graph it on f and f inverse on the same axis, and give the domain and range of each. If the function is not one-to-one, we have to say so. So, we have f of x equals 1 over x minus 3, and because they tell us x can't equal 3, this is a one-to-one function. So, finding the inverse, we are going to, instead of writing f of x, write y equals 1 over x minus 3. And just make note that they already told us x cannot equal 3. Now we're going to switch the y and the x, so we have x equals 1 over y minus 3. And now y cannot equal 3. We'll solve for y. So to get by itself, since y already can't equal 3, that's been noted, we'll multiply both sides of the equation by y minus 3. And what we do to one side, we have to do to the other. And the purpose of this is to get y out of the denominator. And we're not multiplying both sides by 0, so we're safe. The y minus 3's cancel out on the right side. We're left with 1. Y minus 3 times x is left over here. We can go ahead and leave it alone. You don't have to distribute it if you don't want to. It's up to you. I'm not going to because it will make it easier when we graph it. So we're going to divide now both sides by x, but there's a problem we have to make note of. We just divided by x, and we can't divide by 0, so x can't be 0. Do make note of that. That is now a vertical asymptote in our graphing. So we have y minus 3 equals 1 over x. We'll add 3 to both sides, and now we have y equals 1 over x plus 3. Now we can't leave our answer like that. We got to write it pretty. We have the inverse function of f, so f inverse of x equals 1 over x plus 3. Now you probably see why I wanted that plus 3 just off to the side, because now I just see it as a vertical shift of the parent function 1 over x. So it's going to be much easier to graph now. So that's the first part. We have it. Now they asked us to graph f and f inverse. So let's scroll back up to f. We had 1 over x minus 3. This looks like f of x minus 3 equals 1 over x minus 3, where the parent function is f of x equals 1 over x. That's what I'm telling you to start thinking of it as. So because this minus 3 is affecting the x, we have a horizontal shift. Since it's a minus 3, it always does the opposite of what we think. It's actually to the right, so plus 3 units to the right. Let's go ahead and graph. Now, I'm going to graph in red the parent function 1 over x, just so we can get an idea of how he looks. Now we have a vertical asymptote at x equals 0. Oops, clicking things I shouldn't. And we have a horizontal asymptote at y equals 0, and pretend that line is straight. And here's our nice, somewhat nice function. Looks something like that. Not drawn to scale, not perfect at all. Okay, so if I want to draw f, which is our first function, which is 1 over x minus 3, that minus 3 has caused a horizontal, so it's affecting the x axis, shift to the right 3. So we got 1, 2, 3 units to the right from the parent function, which is in the red. That shifts the vertical asymptote over to the right 3. But there is no horizontal effect on it. So we still have y equals 0 as a horizontal asymptote. Now the graph in the green, and it's not drawn pretty at all. You can make this much prettier. You can pick points, and if you like, it depends on how crazy you want to get. So there it is. Now f inverse, let's put him in blue because it's a pretty color, is equal to 1 over x plus 3. And let me double check that because I forgot. So we had 1 over x plus 3. Perfect. Now, from the parent graph, which is the red, because he's 1 over x, we have plus 3 on the outside. So that's like f of x plus 3. That causes a vertical shift up 3, because y always does what we want. So we have the y-axis. We go up 1, 2, 3. Now, that doesn't change what x's vertical asymptote is. X still can't be 0. So we still have the vertical asymptote. But it does change our horizontal asymptote. Instead of at y equals 0, we now have at y equals 0. I mean, y equals 3. Excuse me. Let me clean this up a little bit because this is looking a little nasty. Okay. Now, still the same idea of the graph. We have, let's try to make sure I get this blue in the right lines. Look in there. And over here, oops, I went too far. There it is. Okay. And that's it for graphing. Now we are also asked to find the domain and range of f of x and f inverse of x. Since my graph is getting a little bit nasty, I'm going to go to a new page. Try to pause the video if you're still drawing your graphs, or we'll reference back to it shortly. Domain. Let's talk about the domain of the original function f. F inverse's range is the domain of f. So this is going to be the range of f inverse. Because they're one-to-one function, we found the inverse function. The domain and range are swapped between the two. Same deal that the range of f will now be the domain of f inverse. So you have your graph handy. When you're looking at the function of f, our domain, and let's just take a sneak back, okay? So we're looking at the green function. Domain is the x values. Everything works except the vertical asymptote at x equals 3. So my domain is from negative infinity, somewhere far off in the distance here. As it goes to 3, it kind of gets closer and closer but doesn't touch, right? Not including. Then it starts back up, not including that 3, but it's super, super close, and it continues off on to infinity. So the domain of f, let's call this guy number 1, is from negative infinity until we hit 3, not including it, then union 3 until we go off to infinity. And that is also the range of f inverse. Let's look at the blue graph now. So if we were to look at the range, we're talking about the y. So from negative infinity, starting off towards this bottom area, not sure if you see my little cursor swirling, then I go up until I hit positive 3. It gets really close, but it never touches. Then I continue on. I'm almost at positive 3, but never really there, so not including, all the way off to infinity, which is exactly that we said. Now, the range of f is going to be the domain of f inverse. Let's take a look at our graph. We're talking about the original function f, so we're talking about the green function. Range. So from negative infinity until we hit 0, not including it because it never quite touches. And then, I know it's poorly drawn, but from the 0 there, we go all the way off to infinity. So our range is from negative infinity until we hit that 0, not including it, we'll never get to 0. Union 0 until we go to infinity. Still not including that 0. And that is also the domain of f inverse. So let's take a look at f inverse. Our domain, we have, let's see, the x's. So negative infinity until we hit 0, and then 0 all the way to infinity. And we're looking at the blue function there. Alrighty, so let's make sure I've checked everything that they wanted. They said write the equation in the inverse function. Did it. We graphed them on the same axis. It's messy, but we did it. We have f and f inverse as domain and range, and the function is 1 to 1. It only asked us to say if it's not 1 to 1, so we're done. Thanks, and I'll check back again for a few more extra problems in this section.